Hello students, my name is Sumit Mehta. So today we will discuss about heating effect of electric current. So as we all know that a battery like a group of cell, it is group of cell, or a cell is a source of energy. Okay, source of electrical energy you can say. So the chemical reaction within the cell generates the potential difference between two terminals, like as we have already discussed that a cell generates the potential difference of, let's say, the voltage is V, so it generates a potential difference between its two terminal of V volt. Okay, it's two terminal that sets the electron in motion to flow the current through a resistor. So let's say this is the structural diagram. Okay, so the current flows from negative end to the positive end, and the electron flows from the negative end to the positive end, but the current flows from the positive to the negative, opposite to the direction of the electrons. Okay, so that to maintain the current, the source has to keep expending the energy. Okay, and that too, from where does this energy go? A part of the source energy is maintaining the current that can be consumed by the resistor into useful work. Rest of the source energy can be expended to heat, to raise the temperature of the gadget. So the temperature of the gadget is also raised. Okay, so now we will test, for example, an an electric fan becomes warm if used continuously for longer period of time, continuously for longer period of time. Okay, similarly the bulb. Okay, so that is the heat dissipated, or the heat entirely in the form of the energy dissipated in the form of the heat by the appliance. Okay, so how we can find out the heat energy produced by the appliance is, as we know that the power input to the circuit will be V into I. So the power is Vi, which you can say that I is Q by T also. Okay, and the energy supplied to the circuit is power into time. So energy will be P into T, which is equals to V into I into T. Or you can say that heat is energy in the form of heat is VIT. Okay, and as you can solve, V is equals to IR from Ohm's law, it is I square RT. So the heat dissipated by any appliance or in the resistor is I square RT. So all the appliances have some resistance. So the heat dissipated by these appliances or the resistance is called as heat is equals to I square RT. Okay students, so we will discuss one question based on this. Let me first delete this. So students, here is the question which states that an electric iron consumes energy at the rate of 840 watt when heating is at maximum rate, and 360 watt when the heating is at minimum rate. So the voltage is 220 volt given to us. What are the current and the resistance in each case? So we are given the power input is equals to Vi. Okay. So in the first case, as we know that we have to find out the I, we know P and V. So it is 860 upon 220 watt, which is coming out to be 3.82 amperes current flowing through the circuit. So now, as we know the value of the current and we know the voltage, so from the relation R is equals to V by I, we can find out the value of resistance, which is coming out to be 57.60 ohm. So this is the case 1, and in the case 2, okay, when the power is minimum, which is 360 watt, so in this case current will be 360 upon 220, it is coming out to be 1.64 ampere. Okay, now the resistance will be V by I, which is 220 upon 1.64, coming out to be 134.15 ohm. So this is the case, student, which we have to find out what are the current and the resistance in each case. So now I hope that you guys are pretty clear about heating effect of electric current and the question based on it. So now let's discuss about what is electric power. Okay, let me first delete this. Students, we have earlier discussed also that the power is the rate of doing work is called power. Okay, this is also the rate of consumption of energy. Okay, and power is defined as Vi, and the units of the power are SI unit is watt. Okay, so it is a power, it is the 1 watt. I am writing the definition of 1 watt now. It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Okay, students, so this is the definition of 1 watt. So 1 watt is equal, so 1 volt into 1 ampere. Okay, or you can say that volt ampere. And now the commercial unit of electric energy, is kilowatt hour. So how much power dissipated in 1 hour is called as the kilowatt hour. So it is like 1000 watt into number of seconds in 1 hour. So it will be 3.6 into 10 raised to power 6 joule. Okay, students, so this is the joule is the unit of energy. So 1 kilowatt hour is equals to 3.6 into 10 raised to power 6 joules. So I hope, students, now you are pretty clear about electric power also, and the unit in which our bill comes is the kilowatt hour. Okay, you can check it on the electric bill which you get at your home. Okay, now by this our chapter is completed, and if you have still any doubt or any question based on this, then please do comment in the comment section, student. I will be happy to help you guys there. Thank you. Happy learning.